Hello guys, let's continue with our series. We were doing the DSA questions in the linked list and we wrapped up the third problem in our linked list series. However, since you guys were requesting for another problem in the linked list series, we have come up with a bonus problem to help you out with this. Let's get right into the bonus problem. In this problem, we will be basically using our circular linked list to insert a node, and it will be getting you familiar with the insights of how a typical insertion or deletion operation works in a linked list. This way, you will be able to make a basic foundation in order for other questions which are concerned regarding the insertion and deletions in the linked list. I have written the code beforehand to save yourself some time, because now you are already familiar with the structure of the linked list and the basic codes. So since you are only concerned with the logic right now, I will be assisting you with that logic, and we will go through each of the blocks to understand how the code works and how you can insert a node at the end. Let's begin. So first of all, we have the default classes, and we also have the default node class here, in which we have int data. The data becomes data, the next becomes null. So we simply have a node. Okay, the node is defined here. Next we had node head equal to null, which basically means there is no head. Initially there is no head, right? Since right now there is no new node created, no new node defined, so there is no head. And if there is no head, the linked list is empty, right? Because it is mandatory that you have a linked list's head in order for it to have something, because that's how the linked list works. If you do not have an head, you are not able to traverse in the linked list. If you are not able to traverse, it is of no good, means it does not exist. So here our function public void insert at end begins. It has int data, the integer and data basically, and then we have no new node equal to new node data. So basically we have the node class with a new node variable. This is just the name or variable of our node, right? Just to define our node. And then we have created a new node. Now finally we have created a new node with some data, right? A node that has some data or some value, right? Then we check the condition here. If head equals null, right? If the head is empty or not, basically, right? Because null shows if it's empty or if it's full. Null means nothing, all right? So null simply means empty or non-existent. Okay, so it checks if head equals null. So if it is null, it goes inside, and it goes inside the if block. Once it goes head equals new node, so the new node becomes the head, right? The new node is assigned or reference towards the head, onto the head, right? And then head dot next equal to head, right? So if the head did not exist, we first created a new node, assigned it to the head, then the head dot next was the head, right? So what does it mean when head dot next equals to head? It means there is a link now. The circular link exists now, right? After this we simply return, right? And then you have to pay attention. This is what is happening inside our if loop. right? When our head does not exist, that's when we create our head and form a circular loop. And after that, we have node temp equal to head, right? So here our temporary node, right? Here our temporary node gives head, okay? And we go on to the while looping to check for our condition, which is temp dot next not equal to head, right? So in this, basically we have defined a node temp, and it is referenced with the head of your linked list. So now temp is your head. So while temp dot next not equal to head, it means while the temp node is not the last node, because in the circular linked list, the only way the next of your element is the head is when it's the last element or it's the only element, as we previously saw, right? How the head dot next becomes head when it's the only element, or when it's the last element in the list. The last element of a circular list has a next. What is the next? The head of the linked list, right? So as long as temps next is not equal to head, as long as temps dot next is not last element, we go into the block and we keep on doing temp equal to temp dot next, which means we keep on assigning temp or referencing temp as the next of temp. We keep doing it until we reach the end, the last element, right? Once we reach it, temp dot next becomes new node, right? Or new node can be referenced by temp dot next, and new node's next becomes head. What is happening here? Temp dot next, once we reach the end, temp dot next becomes new node, and new node's next becomes head. And what is head? Head is simply the head, that is the first element of your linked list. So new node's next has finally become head, as you can see, right? Then we simply have the print function, public void print list. It checks if head is null. If the head is null, it simply returns empty linked list. Otherwise, node temp equal to head. Initialize the temp node with head. Do. So in the do loop, you have to pay attention here. In the do while loop, you might already be familiar how the do while loop works. So in this loop, the condition will be executed at least once before the while condition is checked, right? The action will be performed at least once, and only after that the while loop condition will be checked. If the condition is right, the loop will go on once again. If the condition is wrong, the loop will stop. So what does this loop do? Once we have node temp equal to head, we have the do while loop. So we do something. So what do we do? System.out.print temp.data plus space, right? So we are simply printing the data, and once we do that, temp equal to temp dot next, right? So we're shifting the temp to the temp dot next, right? And then let me just this or actually is this good? Alright, so you go into the do loop, you print out temp.data plus space, and then your temp becomes the next of temp, right? So temp is definitely moving, and we have to keep doing this while you have to keep moving forward, right? Like you have to perform this action while temp not equals to head. Until temp gets to the head, we have to keep repeating it, which means we can we can traverse to the next linked list. It's fine, we can traverse onto the next block. Temp becomes temp dot next. At one point temp will come at the last link, and at the last link temp dot next will be head, so temp will become head at this moment, right? This action is performed. Okay, however, what's the condition? Temps not equal to head. Because of this, guys, because of this action will not be performed, because after that temp becomes head, but we are not allowed to do that. Temp not equal to head is what we are allowed, right? So because of this, the loop will stop at the last element, right? And once it stops, simply system.out.println to get the space, right? To get the clear space. Finally, we simply have our main function, public static void main, the default function, main list equal to new main, list dot insert at and 1, list dot insert at and 2, list dot insert at and 3, list dot insert at and 4, list dot print list. So I'll just run it to show you the output. All right, there we go. 1 2 3 4 is successfully printed in this, and basically that's how the insertion works. I wanted to show you because this is also an essential problem that might be a good thing to cover in your linked list DSA practice, right? Once you do this, make sure you practice this at least once or twice to get yourself familiar with the basics and the main crux of this algorithm, right? You have to practice, and once you do, you will be pretty ready to get any of the questions like deletion at linked list, deletion at the end, deletion at any node, insertion at any node, insertion at beginning, and so on, because all of them are pretty same. The logic remains the same. You just have to adjust the links in the linked list, and the logic is pretty much same for all the questions. That was all for this video. I hope you were able to understand everything. Thank you for watching.